Welcome to audience meeting over here. I would like to talk about the stratigraphy of in the area of oil and gas area. From the word strata means layers, and graphy is means description or writing about the rock layers in the field in the area of oil and gas area over here. You can see here earlier understanding, stratigraphy is a branch of geology that studies the sequence of rock formation or rock generation in the Earth's crust of the world here. In summary, the stratigraphy talk about the classification, the naming, the composition of rocks, including the components that describe the age or the history of the rocks formed in the world here. Stratigraphy is study of temporal relationship between sedimentary rock bodies, but also there is the possibility of igneous as well as metamorphic rocks in the world here. So in short, stratigraphy can be interpreted as history of the past geological events and as the dimension of time for sedimentology and the generation of the rock in the world here. The basic understanding is about the stratigraphic principles. There are some principles to understand the basic of stratigraphy based on the physical as well as chemical and component of also generation of the rock formation in the world here. It is generally understood that sediment deposited earlier are below continuously deposited above its younger sedimentary layers or rocks. With this simple understanding, a number of principles of sediment deposition also have been described by several experts in the stratigraphy. I would like to show this picture here about the generation or the process of generating rocks in the world here, particularly in sedimentary rock here. From the process of generation, first there is a erosion in the land over here, for example. But not only rocks that has been eroded, but also there are vegetation and also animals that can die in the history of the rock erosion. And together with the rock, there are also animals and vegetables that are also buried together with the sediment in the basin of sedimentation over here, for example. But not only from the land, but also from the aquatic plants and animals can also be buried together with sediment like sand and clay, and also carbonate rock or carbonate deposits. I'm sorry. By these principles, by this understanding, then the principles are about the first one is about the superposition of the strata. The older rocks usually below the younger rock above it, and this picture is an example of in the Grand Canyon area in the United States of America. The ideal position of a horizontal like this can be easily seen. Where is the older and younger layers of the sedimentary rock in this area. Also, the second one is about the initial horizontality of strata. It is understood by the earlier understanding that the sedimentary rock formed in the basin like horizontal layers over there, and the position of layer is no longer, but the position of layer is no longer essential in their sudden termination. For example, in the deltaic area, sediment not only horizontal but can also have a slope to be deposited over there. And also, the next principle is about this figure show how the principle in the initial horizontality of the generation, like this. But then there is a force from the Earth, from tectonic and also from volcanic activity, that make the geometry of the not horizontal again, but can be have a fold and also fault over here from the tectonic or volcanic activity. The next principle is about the strata lateral continuity. The rock layers develop horizontally outward, but can thin and thicken or taper at the tip of the farthest deposits. This condition can be changed by the structural activity, the tectonic and volcanic activity. This is the picture showing how the principle of strata can change because of the fault over here. This stretching and thinning, shortening and thickening of the layers and so on. And the next is about the principle of cross-cutting relationship. The rock layer is always older than the geological features that cut it. Yeah. For example, the volcanic activity can interrupt magma from inside the wood, inside the crust, through the fault plane, for example, or fracture over here, whereas the sedimentary rock have been existed over there, and so there's a cross-cutting relationship in this feature here. The next important also is principle of rule of inclusion. By erosion process, or also intrusion of igneous rock and so on, older rock can be fragmented and included, in the new rock that form in the area. This picture show that the intrusion of this magma, can include the rock existed before, That's why it's called the rule of inclusion. This one here from process of erosion, with the erosion above the existing rock like this. So the older age rocks can include in the new one here. And that's the principle. The next one is about the principle of faunal succession. As I showed you before, that the deposits of rock can include also fossil, from animal, also vegetable, this figure here, like I showed before, and then by this principle, it's called the faunal succession. It is based on the observation that sedimentary strata contain fossil or flora and fauna. Here is the example of how we can compare, the sequence of sedimentary rock here to see how the faunal succession can be seen in this area. For example, here there's a sequence of rock layers over here, and the other one is in the area over here. We can compare it to make a correlation. We see that although the rock is different, but the fossil is similar here. So there is a relationship, correlation between these two layers over this two areas over here. The most important also is also about the unconformity. Two different rock can have different edges. because of the process and also the history of the formation. So there is a different age. It's called the unconformity. Also the important understanding is about the types of unconformity. The first one is called disconformity. You can read, you can find in the reference book, non-conformity and so on. This is the picture depicting how disconformity and non-conformity looks like here. The next one is about the angular unconformity here. We can see the outcrops in the field, and we can see that this different age, not only different rock, but also the position, the geometry of this. The lower older rocks have a slope over here, and then make an angular relation, and then this is called the angular unconformity. The next principle, basic is a paraconformity and also a biconformity. And this is the figure showing how the paraconformity and biconformity. The paraconformity is parallel but different age. This one here, there are two. It's called biconformity. Biconformity, I'm sorry. The first unconformity is the below one here, and the second unconformity is the above here. The next understanding is about the nomenclature. There are several standards of stratigraphy that have nomenclature. Here is the basic of the understanding of the nomenclature of the stratigraphy. There is a lithostratigraphy, biostratigraphy, chronostratigraphy, and so on. Chrono based on the time relationship, the magnetograph from the magnetic polarity. Chemostratigraphy is a chemical characteristic. That's the basic for understanding the nomenclature of the stratigraphy here. The most common is lithostratigraphy, based on the lithology of the sequence of stratigraphy. The next is we can see, you can read in references and so on. The most recently developed is called sequence stratigraphy. Here's the basic understanding. Sequence related to the continuation of the rock unit associated with the deposition. Not only about the components or rock characteristic, but also the genetization, the generation of the rocks here as a basic form for the sequence stratigraphic analysis. Here is an example of why sediment are not only parallel but can have a slope over here and also different thickness and so on. This is the basic of sequence stratigraphy. This is the nomenclature in the sequence stratigraphy. There is called a parasequence bed and so on, amino set and so on. This is an example of the sequence stratigraphy, and this is the basic for analysis of sequence stratigraphy from the lithology, from structure and so on. Then from the generation process, and then we can predict the sequence stratigraphy of the area, of the oil and gas area over there. Thank you for watching this sharing of science and knowledge. You're welcome. Thank you very much.